Everyone, welcome to the channel. I hope each and one of you are having a wonderful day. Today we'll be looking at this problem called longest substring without repeating characters. And in this problem we're given a string and we want to find the length of the longest substring without repeating characters. And so we see this input A, B, C, A, B, C, B, B. We see that when we have A, B, C, this window here, there's no repeating characters, and when we have BCA, it's also 3, and CAB also 3. And as we scan through, see, this one doesn't count as 3 because B is repeated, so it's actually 2. As scan through, the longest substring is 3. And in this example, since the characters are all the same, the longest length is 1. Now the main idea for this problem is we scan through the string. Take this for example. We scan through with the start pointer, and we move on. This will be the current, and we keep on moving and count the length of the substring, and as soon as we hit a character that's repeating, then we move the start pointer until we reach a point where everything within the window is non-repeating. And so now we have BCA. Once we move this, we see B is repeating. So we have this CAB, and we see that it's unique. And at each point that we move, that we iterate through the string, we will cache that result. So initially this started here with A, B, C. Okay, A, and moves on to B. So it's A, so the maximum is 1. And then you go to B, everything is still unique, so now the max is 2. Then we go to C, everything is unique, so now the max is 3. However, once we hit A, we see that A is repeated within this window from the star to the caret A, B, C. So that means we move our start pointer. And once we move our start pointer, we know that it is 3, and we can move this. We iterate to the next because we already have a unique substring, and then we see that the B is not unique, so then we keep removing things in our window until we no longer have a substring that has repeating characters. So using words to summarize that. Case new string. Case that string case that new character prevents substring from being unique. And we have the case where, well, we could just do that case because we're addressing that case, and then the else case we would solve it in another way. Yeah, when this case happens, we want to move all characters in substring starting from left until we have a unique substring. And then at each iteration, cache the maximum substring. And on the outside, we iterate each character in string. In string S. And we have to cover our base case, or a few base cases, when substring less than or equal to 1, return length of s. Because if the substring is length 0, we know the longest would be 0. And if the substring is 1, the longest would be 1. And then in the end, we return our maximum. Yeah, so we cache the maximum length of substring, not cache the maximum. And so now we could code things up. We could see, okay, space case, length of s less than or equal to 1, return length s. Iterate all the characters in string s. Right. So one thing I forgot to mention is we need to keep track of what is in our substring. So we will use the hash map for that. So prior to that, I need to define the hash map. So I'll initiate the hash map. And we said that we had the stars and the caret before, so there needs to be a start pointer. We'll start at 0, and then max length, this will be what we use to cache what the maximum length of a substring is within this string. And so yeah, we see if we see a key exists in the hash map, it means that we no longer have a substring that is unique, has all characters unique. So we will need to keep removing all the keys we'll need to keep removing all the keys within the substring until we have a unique substring. And so we delete what is in the start pointer. Whatever the start pointer points to, we'll delete that key, and then we'll increment the start pointer, which will indicate us deleting the next key. Then we add the current character into the substring. And we'll just set the value equal to 0, and then we cache the maximum length. And for each substring, let's say we have this as substring, star is here, star is our start pointer, and the caret is there. So I would equal the caret, which equals 2. So we do 2 minus start pointer, 2 minus 0, that's 2. And we see the length is actually 3, so we would have to do plus 1 for that. And then we return the max length. So yeah, this is the case where start pointer prevents substring being unique. And then the while loop is where we're doing this. Then we cache the maximum length of substring. Then lastly, we return the maximum length. Let's check out the code, make sure it looks good. So length of s less than or equal to 1, return length of s. Then we have a hash map, start pointer, max length to cache, and then we iterate through the string. And then we check if each key is within the hash map. Keep removing keys in the current substring until hash map, that looks good. And we delete each of the keys that start pointer points to. Increment the start pointer so we could check if the next key needs to be removed, or if removing the next key would allow the substring to be unique. And we add the current character to the substring, or substring window, which is defined by the hash map. Then we calculate the max length. Okay, looks good to me, so I'm going to run the code. That looks good. Try other test cases. All right, so it looks good. Let's try submitting. All right, looks like the submission worked. Let's talk about runtime for a little bit. So for this algorithm, we're iterating through each of the characters. And so let's say we have n characters. N characters, and each time let's say k is the longest valid substring plus 1. And it's plus 1 because once we know that it's the longest valid substring once we see that the next character makes it invalid. And so each time we iterate the string, it is possible, the worst case is that we need to go through the longest valid substring and remove all the characters except the last character from the window. So an example would be A, B, C, D, and then D. So we have A, B, C, D, length of 4, and once we hit D, we need to remove A, B, C up until D. So the runtime is O n times K. And then our space complexity is O of K because we have a hash map that will store all of the characters for the unique valid substring. So that's it for today. I hope you guys learned something and have fun. If you like the content, please share with other people that you think will also enjoy it. And follow me on social media if you want latest updates. Thank you so much and happy learning.